Welcome to the 2022 workflow for Revit, Robot, Advanced Steel, and Inventor on ACC. I am Lina El Khoury, and I have with me Masan Ahmed and Hang Nguyen, and together we will be presenting this session. Let us go through some introduction. I'm currently the BIM manager at Diamond Schmidt in Vancouver, BC. I have many years of experience in architecture, interior design, building systems, and building manufacturing, specializing in BIM technologies. I have trained and coached many teams in multiple design and subcontracting AEC firms, and I've also been speaking at AU for a few years now. You can read more about me later. I'm going to pass it to the next speaker, Masan.
Hello, everybody. My name is Mahsan Omid, and I'm a BIM specialist and a technical consultant at SolidCAD here in Canada. I've been working in the field for more than 15 years now, working with all the AEC disciplines. Some of those went in the construction firms, in the construction industry, some in academia, and some as a consultant. Also, in the past 5 years, I've been active in BIM 360 and all the different other cloud services, mentoring, consulting, managing, and administrating services, as well as training and helping some of our clients admin theirs. In this AU session, I have the pleasure of working with Hang and Lina for introducing the workflow, introducing what ACC has to offer, and answering some of your cloud questions in the Q&A session. Thank you. Hang?
Thank you, Masan. Hello, everyone. I'm Hung. As you see, I have many years of experience in Autodesk products, 27 years. I work with architecture and manufacturing fields. I've been doing a lot of work relating Revit, Inventor, Fusion 360 areas, and do a lot of simulation for the past few years. I presented in RTC, Indian Festival of Architecture, GANBIM, and of course, my favorite is Autodesk University. I think I started from 2013 until now with the 2021. Let me pass back to Lina.
Thank you, Hang. I'm going to go through the class description. In this session, we'll show the seamless workflows between Revit, Robot, Advanced Steel, Inventor, and Dynamo. The Dynamo material will be in the handout. You'll learn how to create an Advanced Steel model from a non-parametric model, synchronized to Revit Structural, and Robot for structural steel code check and optimization. This class will cover new features and changes between BIM 360 and Autodesk Construction Cloud, how to share Revit, Robot, Advanced Steel, and Inventor models, exploring 2022 interoperability between manufacturing and construction industries through AEC and MFG. This class objectives: you will learn how to set up and manage Autodesk Construction Cloud workflow for Autodesk 2022 products, effectively work with the 2022 workflow for Revit, Robot, Advanced Steel, and Inventor, effectively use Robot Structural Analysis 2022 for structural steel code check and optimization. And also you will learn the seamless workflow between construction and manufacturing industries. Our topics: BIM 360 versus ACC platforms, Autodesk Inventor, Revit, RSA, Advanced Steel workflow, and going beyond AEC workflow on ACC. Now let's start our demos. Our project for this year is called Project Water Slide. However, we will not be working on the whole water slide, but we will only focus on the lifting frame that you see within that red rectangle. Let me describe the workflow. We will start by taking a non-parametric assembly from Inventor into Advanced Steel for creating a parametric model with bolted connections. We will then synchronize the Advanced Steel model to Revit structure for analytical setup. The Revit analytical model will be analyzed and optimized using robot structural analysis. After steel optimization in RSA, we will update both Revit and Advanced Steel models. When all of this is done, we will link the Revit model back to Inventor to replace the non-parametric assembly. We will be using the Autodesk Construction Cloud platform, referred to as ACC, to demonstrate this interoperability between manufacturing and AEC. I'd like to mention that we will be mainly showing the workflow in this session. I will now pass it on to Massan to present the ACC platform. Massan?
Thank you, Lina. What is ACC? ACC, that stands for Autodesk Construction Cloud. It's the BIM 360 Next Generation rebranded and much more integrated platform. I am going to be talking about what is Unified Construction Cloud, also known as ACC. What is ACC and what is the difference of BIM 360 and the ACC platform? And what has changed in the licensing from BIM 360 to ACC. And finally, I'm going to be introducing our project on the ACC for you. What's new in ACC compared to BIM 360 Next Gen? If you remember the BIM 360 package, the red fields in this diagram are components that were there in the first generation of BIM 360, also known as classic version. Then comes the next generation, also known as BIM 360 Next Gen, the gray ones, such as BIM 360 Docs, BIM 360 Design, Model Coordination, and Build. Taking the same concept, we are taking the idea of BIM 360 platform and further that into a unified platform. It can be translated as a diagram like this. BIM 360 Docs, BIM Collaborate, BIM Collaborate Pro, and BIM Build. There is also a brand new component in ACC called Autodesk Takeoff. Very similar to BIM 360 Docs is the document management component that gives you access to all the features in the document management module, such as issues, markups, reports, file sharing, etc., etc. The good thing about the Autodesk Docs is that if you own an Autodesk AEC collection, it comes under that free of charge. Then comes Autodesk BIM Collaborate. Think about BIM 360 Coordinate or Glue, or all of those modules that perform clash detection and model coordination. Now, one of the interesting things here is that the BIM Collaborate Pro, or the evolution of BIM 360 Design, that includes Autodesk BIM Collaborate and model coordination performance, also accounts for collaboration in plant 3D and civil 3D. Next, Autodesk Build gives you field management, project management, asset components. It also includes cost management module in the unified platform. It also gives you access to your classic builds such as Plan Grid, BIM 360 Build, and Field. And the Takeoff module, as the name implies, is for quantification tool. It gives you 2D and 3D takeoff of your project content. The nice thing about it is that even though ACC and BIM 360 are not the same services, they are not completely different in terms of workflow and licensing from each other. They are very similar. While we are on the licensing subject, let's talk about licensing. Typically, what happens in BIM 360 was that if I'm inviting someone to my project as a prime consultant and it's on my hub, unless it is for the BIM 360 design, I'm assigning them a seat from my license pool. The only one that is allowed to bring their own licenses, also known as bring your own license, on anybody else's account is BIM 360 Design. Now take a look at the ACC on the unified platform. Every single module is now bring your own license and will be managed by the named user. So you don't have to worry about providing seats for all of the subs and engineers. I'll be happy to answer any further questions on the Q&A session. Okay, let's get on our project. Getting on the ACC platform, let me show you quickly how to log in Autodesk. The list of the projects that are with the blue globe icons are made on ACC, and any of the projects that were made in BIM 360, you will see it as a typical blue B icon. In Docs, the structural folder is contained of Revit, Advanced Steel, Robot Analysis, Inventor Pro, and Event Dynamo, and 3ds Max. We also made a quick intro video to our project that shows the snap of park water ride as well as the lift frame. Okay, let's get back to the project folder. We are going to be seeing the drawing first from the inventor, and all of the details of the water park slide. Then we are going back to Inventor Pro folder, locating the assembly file of the inventor. It is called STC Standard 15 meters IAM. It is surprisingly very well coordinated with the DWG and the inventor file. As you can see, all of the details are coming on the platform. In this project, for only showing you the workflow in the presentation, we do only focus on the sliding structure, the lifting frame. So this is the inventor model. Let's go back to the inventor drawing. On ACC, when you open the Sheets menu, it has more sheets on the drawing that you can see, which shows the detail of the lifting frame. Later, Hong will show you how we use this sheet in Advanced Steel to reinvent the Advanced Steel details. With that introduction, let's hear more from Hong.
Thank you, Ms. Ann. The first step of our workflow is taking the model from Inventor to Advanced Steel. For the information, the water slide that you see there is a SolidWorks model. But with Inventor AnyCAD feature, we can now open almost any CAD format out there. Inventor AnyCAD allows us to reference or convert any 3D CAD to Inventor. However, when it's coming to Inventor, the converted model will be a non-parametric one. So in our workflow, the assumption is that we need to recreate the moving frame that you see on the animated frame up there and turn it to a parametric model with bolted connection, and we need to produce the fabrication drawing for all of the parts. So let me just quickly show demo of the portion. Before exporting the model to Advanced Steel, let me just quickly show you that the own Inventor project can now be operated through ACC platform. As you see, my Inventor project is on ACC, which allows me to work from anywhere. Let's open the water slide assembly drawing. The speed that you see in this demo is the real-time speed, and I deliberately just want to test to see how fast the Inventor model would able to open during my recording. From the drawing and on the right click, I open the water slide assembly, and let's take a quick look at the lifting frame. As part of a fun, I add 3 AU cube there. The lifting frame is used to lift up the bolt and move them to the left or right side of the platform for maintenance. I also have a motion constraint already added. So let me just show you quickly how it works. Inventor is fun to play with. It allows dynamic motion study and all sort of animation and exploded view if needed. The structure frame is belong to a sub-assembly. So in order to export to advanced steel, I just simply open the sub-assembly and simply have the part saved as a DWG format in order to use in advanced steel. I will then just save the exported model right on ACC with the name called Frame from Inventor. Moving to the second part of the workflow where advanced steel will be used. In this part, I will give a quick intro to advanced steel modeling. As you know, advanced steel modeling is known for its intelligent structure object. It has parametric steel connection, a building steel connection design engine. It has a lot of stairs, railing, and cage ladders, sheet and plate metalwork. And the best part is seamless integration with Revit and robust structure analysis. So let's take a quick look at how Advanced Steel can handle the modeling part. From Advanced Steel, I open the frame from inventor.dwg with export out from Inventor and save on ACC. To create a steel member that match to the solid, I need to create some AutoCAD line that go to the center of the solid part, similarly presenting the steel shape. Using mid of 2 point in AutoCAD, I could draw on the line easily. So let me just hide the solid to show you that. But also because to save time for this presentation, I redraw on of the lines and make it ready to convert them to columns beam using advanced steel beam from line. This process will involve with using SSS route 7.5 for the column and keep repeating this so that I can turn on of the other line into a W and show the 10 by 12 to match to the Inventor model. For bracing, I could also use the same command and assign a SSS. I just choose the 5 by 5 by a quarter so that I can create some interesting connection later. So now let's just take a quick look of how we can add the connection. In order to add a SharePlay connection, I noticed that the column is really short. So in Advanced Steel, it came with multiple tools that allow you to trim and extend the member. So just verify the face and you keep hitting on the column, you see that it extends to that. And now it makes it easier for a SharePlay connection. Whatever connection that you create in Advanced Steel can be saved in the library for sharing or future use. So I use one from the library and I continue to extend other column to meet the same condition of the SharePlay connection that I add in earlier. So now the best part is to propagate this connection. Suppose you have thousands of similar conditions you want to populate them on. So you propagation. Next step is just simply save the model on ACC in order to do some fabrication drawing. So on AAC, I save the model at frame DWG. Now, I also need somebody who prepare the analysis model for me. To save some time, I already done on of these. So now I reopen the complete model. And from here, I need to export out to someone who helped me to create an analysis model in Revit. So I kick out the file and save it under the our project in ACC and name it frame SML. The second portion of Advanced Steel that I would like to show in this workflow is the way how Advanced Steel create fabrication drawing on ACC. Advanced Steel fabrication drawing is a automatic process if you would like to do so. It could also do general arrangement drawing, sharp drawing, build material. It supports CNC. It have a nice tool for document management that is keep on of the updated drawing and revision for you. And it did a great job on revision control. So with that in mind, let's quickly see how Advanced fabrication drawing on ACC work. So with the Advanced Steel model still open, before you can generate any drawing, you need to number it. So you can turn on the single part assembly parts, and the numbering dialog box allow you to browse through every single piece on the 3D model. From this, if you like to create a fabrication drawing for every single part, you just hit the process drawing suite. In there, you can create your own process implemented in here. In this demo, I just use something under the user that I create everything on B side. And while Advanced Steel trying to create fabrication of every single part in the background, I would like to mention that compared to Inventor, for example, that it where a automatic creation of drawing is not a feature in Inventor. And the comparison could be very easily understood where in Inventor you need to take time to put out the part and put on the drawing and put in dimension and so on, and where Advanced Steel is the automatic process. And more than that, when the process is done, and if you use ACC, then surprisingly, when you go into the folder on ACC that I store the file called frame.dwg, then Under the same name, Advanced Steel will create a folder called Frame with two subfolders called Database and Detail. And every single piece of steel, it will put it on the drawing and with the dimension and everything to it. So let me just browse through some of them. That the assembly of the beam, so other assembly come from the model. Ultimately, play work can also generate it. So let's take a quick look at one of the part, for example, randomly, and you see it quite nicely presented with proper dimension and so on. With that, I will pass it on to Lena for the next step on our workflow. Lena?
Now I will show how to set up the analytical model in Revit from Advanced Steel. In this Revit and Advanced Steel workflow, I will create the Revit model from the SMLX file that Hung exported to ACC, map the steel sections, set up the boundary conditions, apply loads to the Revit model. I will also have to create load cases, then check the analytical model consistency and adjust it by adding analytical links. Let's get to the demo. In Revit, I'm starting a new project and I am using the structural template we saved in the ACC project files. The new file is opening. Now that it is open, I will use the import tool from the Advanced Steel extension to bring in the SMLX file that was exported earlier from the Advanced Steel model. It is also stored in the ACC project files. The sections from Advanced Steel need to be mapped in Revit. To map them, I would be choosing the corresponding families and types from Revit. And I had already preloaded steel sections and columns in the Revit template to make this mapping easier. And if I had forgotten any, I could always load the family from the Revit library. So now the frame is being built. I will ignore the warning and shortly we will see the frame. The beams came in as mapped. The columns, we have the family and types are as mapped, but the structural material should be replaced. So in an elevation, I'm going to be choosing the columns and we'll change the structural material to a steel material. I will choose the steel ASTM A53 and click OK. Next, I will make the modifications to the levels in the elevation. Level 2 is redundant and I will delete it. The hoist level came in with the steel frame from Advanced Steel. I'm just adjusting the symbol. And renaming it to level 2. There are no elements on level 3, so I will delete it. Next, I'm going to be working with the analytical model, adding some loads, adjusting the analytical links, and getting it ready for analysis. But I noticed that the analytical nodes are not showing, so I'm turning them on from the visibility graphic. Now that I see the nodes, I can apply boundary conditions to the bottom of the columns. And then I'm going to add loads. It's going to be hosted line loads to the longitudinal beams. When selecting those loads, I realized that in the properties I had chosen a dead load where I should have had a live one. From the load cases tool, I'm going to add a new one. For nature, I'm going to choose live. Category, I'm going to choose live loads and rename it to ML and click OK. I'm going to select them again. Now I'm going to change them to the new case load that I created, load case that I created. And I'm going to change the dead forces and click apply. The loads changed. And I'm going to now check the analytical model consistency. I see I have some warnings, and that is due to the distance tolerance between nodes. So I'm going to adjust that by adding analytical links. And finish. I would now create a sheet on which I'm going to be placing a couple of 3D views, and I will also create a schedule for the steel sections. I'm bringing in the 3D view, adjusting its scale. I'm going to create a schedule for the structural framing. There are many parameters. I'm going to be adding few that I'm interested in. That's going to be the count, family and type, length, mark, and a couple more. And click OK. Adjusting the schedule. I will adjust it more when I place it on the sheet. I will also bring in the analytical model and scale it to match the 3D view. Reposition both. My sheet is ready. The next step will be to send the Revit model to robot structural analysis for further structural analysis. But before doing so, I have to save the file. Saving the Revit model to ACC, to the project files, under the Revit folder, and renaming it Frame from Inventor, and save it. Now I will link the Revit model to robot structural analysis. I will choose robot structural analysis link from the robot analysis tools. And select send to intermediate file and click OK. I will also save the file that I'm creating to RSA. Keep the same name as the Revit model. Of course, it's a different extension. Click No for the report. And now the model is ready for Hung to take it and make the analysis in robot structural analysis.
Thank you, Lina, for preparing the Revit analytic model and get me ready for the workflow of how to use structural analysis and the steel optimization workflow. Robot structural analysis workflow is similarly linked to Revit. You could create a RSA model directly from Revit to an XLMXS format. In the demo that I'm going to show you, I will show you the basic, very basic RSA analysis, how to understand the basic of steel optimization module. And after analysis, I will update the Revit model using the RSA results. Show you a bit of result explorers that it plug in Revit, and you will see how all of the Revit drawings update include the schedule and so on. So with that in mind, let's go straight to the robot structural analysis steel and steel optimization demo. So from RSA, I just fired up a template file, and in that, instead of building the model, I just go to add-in integration and I will update the model link directly to the SMXS model that Lina put it on the HCC for me under our folder called RSA. The verify that Lina just kicked it out for me. It doesn't take long. The model now transferred to my RSA robot structure, include the analytical links that she added for me, and include all of the moving load that she initially set it up. All I need to know now is to run the calculation, and to that I can show some of the result in here, a moment on Y direction and something that I need to pay attention to and so on. So on the steel aluminum design, it's another module. I can do a secondary calculation, and where you see that it robot structure tell me that the cobalt member is questionable right there, the 16 by 26. So I just type in W in the code and ask robot to replace the member for me, and it suggests the A31 as the taker member. After doing that, I need to recalculate the analysis, and let me just show you that robot actually replaced the member. And now I need to do a secondary calculation, and now you will see that everything is passed now with the green part, and the ratio is very low. So it's just the basic introduction. So with this, now I'm good to go. So I just want to show the workflow of how to update back to Revit, log in with my name, open Lina Revit model, and to the robot analysis link, I update the model and the result using direct technique and carry the analysis package over. It won't take too long. Let's just give it a 30 seconds or so. The model will update, and I would like to show you some of the changes to the model. So we should go directly to the schedule, and you see that now it's replaced with the thicker model, and it update on the drawing with the WA by 31. On top of that, I can also show the result. In here, I could show the reaction, and you see it have on mm, the uh, the color code that is show what happened to the member, and here I also show the result on the member, and I can overlay on top of the Revit model for documentation and so on. One thing I still don't know is how I'm gonna make this color code bar smaller so it can fit on the drawing. That is my problem. But anyway, now everything is ready to go. So all I need to do is save the Revit model to be brought back to Inventor. So let's complete our workflow by bringing the Revit model into Inventor. In this Revit and Inventor workflow, let us look into the new 2022 interoperability between AEC and manufacturing. In this section, I will show how to open Revit using Inventor, how Revit model can be referenced or converted into native Inventor. Part and assembly feature in Inventor can also be added to the Revit model. We can add constraints for motion study on Revit model. Reference Revit model can also be used for assembly. Drawing can also be created directly from it, and how Revit schedule come across as Inventor bar. So let's switch to Inventor, and let me just open the Inventor assembly. So our task is to replace the Inventor part with the Revit model that we just created. So I open the sub-assembly and check on the motion constraint, and everything's still there. Now I will just open the Revit file that was created earlier with Revit as a reference in Inventor. A few seconds, the model come into Inventor. Take a quick look. Now I just go ahead and save the Inventor sub-assembly that come from Revit onto ACC. Name it structure from Inventor. From Revit, sorry. Let's just continue. Let me just quickly show you how things come across to Inventor from Revit. Expand the sub-assembly. I can see all of the member will be there, and you could also override it with different color in Inventor. You could also build additional feature like work plane on top of the Revit model. Even is come over at a reference. So now it's about time to replace the old frame with the new one that has come from Revit. So I would just simply make a copy and paste the Revit model into the sub-assembly, spin it around. The reason that I add the work plane is just easy for me to do the constraint. So similar to Revit, the align command in Revit, you can align everything to the existing frame. So that's the technique I'm trying to do now. Try to put into the existing position of the dummy part. So when everything is done, now is about time to turn up some of the work plane so that we can see things better. I also want to check see if the motion constraint is still there. And yes, it is. Now time to generate some drawing. I turn off the work plane. And let's just quickly show you how the schedule from Revit come over to Inventor at Bill of Material, or we call it BOM. You see, everything's come across very nicely. As you see, even with the connection, the column, frame, and all of these originally is from Advanced Steel to Revit and now into Inventor. Everything fine now, so I will quickly generate a DWG drawing, 2D drawing out of Inventor part. One isometric view is good enough. And now I can take the scheduler, but now it's the BOM in Revit, and lay it on top of my Inventor drawing. On top of that, you can also use your add balloon to the model as all of the Inventor user always do. So now it's a good time to conclude everything, and I will pass the next step to Lina to conclude our workflow.
As you know, the structural and manufacturing workflow involves the engineers, the detailers, the fabricators, and the builders. In our session, we discussed the flow between the engineers and the fabricators only. We started with a conceptual design from Inventor. We created a parametric model with bolted connections in Advanced Steel and created fabrication drawings. To make sure the selection of steel members was adequate, we linked the Advanced Steel model to Revit for setting it up for analysis in RSA. After optimizing the steel, we uploaded both Revit and Advanced Steel models. We then ended the workflow by linking the Revit model to Inventor for motion study and further interoperability. The structure workflow can be expanded further to the builders who may use Navisworks and collaboration on ACC, as you can see in this chart. I'd like to thank you for listening to our session.